Hi, my name is Simran Nanda, and I'm a R&D engineer at Keysight Technologies. And today I'll be showing you the filters on the PA2203 Integra Vision Analyzer. Okay, what I have here is a VFD driving a three-phase motor, and I'll be looking at just the voltage waveform. And first off, you can see the voltage waveform up top. And if you stop that, and it's hard to trigger on, but if you zoom in, you can see what it's actually made up of is a PWM signal. It's a two-level PWM signal. Now, to be able to see the fundamental of that signal, what you can do is turn on filters, go to the filter menu, channel 1, voltage filter. And you have a selection of high-pass and low-pass filters at some cardinal points. I'm just going to pick the 1 kilohertz filter just to see the effect that it has. And you can see with the 1 kilohertz digital filter in line with the measurement, the PWM signal has turned into the fundamental sine wave that the device most likely sees. You know, depending on the actual low-pass filtering of the device, it may see something different, but this makes it easy to trigger on the signal, much easier than on a PWM signal coming out of the VFD directly. And now I'm going to switch over to the function generator. Okay, now I have my function generator hooked up, generating a square wave on both V1 and V2 inputs of the analyzer here, and I just wanted to show you the effect of the filters on a square wave. If I can zoom in here, you can see, let's back up a little. Okay, you only see one waveform, but really there are two. They just are identical, so they look like they're sitting right on top of each other. So I'll go to channel 2 voltage and turn on the filter. Let's start with the 100 kilohertz. And you can see the higher frequencies have been filtered out, so the rising edge is not as sharp. And I'll keep going with that, and let's just walk through some of these filters. And the thing to notice here is the filter does say, the two channels do stay lined up. Since it's a digital filter, we can take out the delay that the filter adds, and to make sure the channels stay lined up, which is important for phasers and for power calculations in general. And if you have any skew setup that you have to take out the skew of your wiring, the filters won't interfere with that. Now let's switch over to a sine wave just to show you the filter response. We'll do a sweep from 10 hertz to 500 kilohertz. And let's see here. I'll move this guy over. We'll turn the sweep on. And again, you can see the yellow is channel 1, which isn't being filtered, and the green is the channel that is being filtered. And the 200 hertz filter, you can see the roll-off. And you know, as you step through these filters, you can see the effect that it has. I won't go through all of them. We'll just jump to the 100 kilohertz. Get that on the screen. More time. Yep, there you can see it passes most of the frequencies and up near 100 kilohertz, cutoff being right about there. It rolls off. And the other interesting, again, thing to notice again is that the filters do stay lined up. So if I zoom in here, even as we're sweeping and filtering the signal, the two lines do stay in sync. In summary, we looked at the filters on a real application, which was the VFD feeding an AC motor, and saw the effect, the advantage of using the filter, so it makes the waveform easier to trigger on, and it kind of simulates what the actual motor is going to be seeing. And then we also looked at if you sweep the input signal, we looked at the characteristics of the filters.